Let's take a look at another example where we want to solve a system of linear equations, but we have to set up the system first. So again, this is a really nice problem for my nursing students. Let's suppose that the dietitian comes in and says that she has a patient who must have a meal that has 66 grams of protein, 94.5 grams of carbohydrates, and 910 milligrams of calcium. And at the hospital that night, the food service tells you that the dinner for that night is chicken, corn, and 2% milk. So we also know that each serving of chicken has 30 grams of protein, 35 grams of carbohydrate, and 200 milligrams of calcium. And we also know that in each serving of corn, it contains 3 grams of protein, 16 grams of carbohydrates, and 10 milligrams of calcium. And then we also know that each glass of milk has 9 grams of protein, 13 grams of carbohydrate, and 300 milligrams of calcium. So what you want to figure out is you want to figure out how many servings of each food item, so how many servings of chicken, corn, and milk, right, should the dietitian provide for the patient. Assuming that the dietitian says that the patient should have this amount of each type of protein, carbohydrate, and calcium. Okay, so the first thing that we want to do is we want to write down some important information about what's required. So the dietitian is requiring that this patient have a certain amount of protein. So we need to make sure that this patient has 66 grams of protein, 94.5 grams of carbohydrate, and 910 milligrams of calcium. Okay, so I always like to write down the important pieces of information when I have a word problem. And then I go to the question. It's asking, how many servings of each food should we provide for the patient? So I don't know how many of each serving. So those are going to be our variables. So the number of servings of chicken. Are we going to give the patient 1 serving, 2 servings, 3 servings? We're not sure yet. So let's just call that X. Okay? What about the number of servings of corn? Again, are we going to give the patient just 1 serving, 2 servings, 3 servings? Not sure, right? So let's call that Y. Okay? And what about the number of servings of milk? Are we going to give them 1 serving, 2, 3? Not sure. So let's call that Z. Okay? And now what we're going to do is we're going to set up a table of sorts, all right, to write our equations to see how these are all related to each other. Okay, so we called X the number of servings of chicken, right? I'm just going to make this my first column. Okay, I don't know how many servings of chicken I'm going to give my patient, but I do know that in 1 serving of chicken, there is a certain amount of protein in it. There's also a certain number of carbohydrates, and there's also a certain number of calcium in 1 serving of chicken. So we're told that in 1 serving of chicken there is 30 grams of protein, 35 grams of carbohydrates, and 200 milligrams of calcium. So what this means is it says that if I give my patient just 1 serving of chicken, this is how many grams and milligrams of each of these nutrients that the patient's going to get. But let's suppose that I gave each patient 2 servings, or let's suppose I give the patient 2 servings of chicken. So if X were 2 servings, then that means that the patient will get 60 grams of protein, and then 2 times 35 means 70 grams of carbohydrates, and then 2 times 200 means 400 milligrams of calcium. Right? So if we check the requirement by the dietitian, we're still within the limits. So we're still, within the 66 grams of protein, right? We're under the 94 grams of carbohydrates, and we're definitely within the 910 milligrams of calcium, all right? So instead of writing 2 or 1, right, or 3, representing the different number of servings of chicken, let's just call that x, right? So if x were 1, we would multiply 1 times 30. If x were 2, we would multiply 2 times 30, etc. Okay? All right, now let's take a look at what's in a serving of corn. So in 1 serving of corn, there are 3 grams of protein, 16 grams of carbohydrates, and 10 grams of calcium, or 10 milligrams of calcium. But same thing, assuming that we give the patient more than 1 serving, we would take the number of servings and multiply it by however many grams of each nutrient is in that food item. Okay, so you're already seeing a pattern. We would approach the number of servings of milk in the same manner. If we knew that 1 serving had 9 grams of protein, then Z times 9 would give us the number of grams of protein based on the serving size of milk. Okay, and then we know that there's 13 grams of carbohydrates and 300 milligrams of calcium. Okay, so what we need to do is we need to make sure we give our patient the correct combination of the correct servings of chicken, corn, and milk, so that when we combine the number of servings of each of these food items, the patient has the correct total number of protein, carbs, and calcium. So in total, we need to make sure that however many servings of chicken, corn, and milk we give the patient, right, in this first row, we need to make sure that in total, the patient is going to get 66 grams of protein, okay? In the second row here, in total, we need to make sure that the patient is going to have 94.5 grams of carbohydrate. And then in this third row, we need to make sure that in total, based on how many servings of each food item, we need to make sure that the patient gets 910 milligrams of calcium. So notice that what we have here is we have a beautiful system where we have 3 unknown variables and 3 equations. Right, so I'll call that equation 1, equation 2, and equation 3. And now that we have our system, we can solve it. So to solve this system, I'm going to go to my calculator, and I'm going to use an augmented matrix. So I need to set up my matrix. So for our matrix, we need some rows and columns. I'm going to set it up so that my first column represents the number of serving size of chicken, X. My second column is going to represent the number of serving size of corn, Y. And my third column is going to represent the number of serving size of milk, which we called Z. And then, of course, our last column is going to represent our constant, which was the total number of grams and milligrams for each nutrient. So my first row here is going to be the coefficients in front of the variables for my first equation. So that's going to be 30, 3, 9, 66. My second row here is going to be the coefficients in front of the variables in the second equation. So that's 35, 16, 13, 94.5, and then I'll do the same thing for my last row. 200, 10, 300, 910. Now our next step is we need to reduce our rows to get into echelon form, which means that my first row needs to look like this. The leading coefficient is going to be 1, followed by a 0 for all of the other variables. My second row is going to have a leading coefficient in the second column, and then all the other columns will have zeros. And then my third row, the leading coefficient is going to be in the third column, meaning that all the other columns will have zeros. And then, of course, we'll come up with a number to represent the solution to the system. So I'm going to go to my graphing calculator, and I'm going to use my calculator to solve this problem. Oops. Okay, so I'm going to go into my matrix, And I'm going to edit a matrix. All right, this is a 3 by 4, so 3 rows, 4 columns. So this is a 3 by 4 matrix. And then now I need to just enter in those coefficients and constants. So 30, 3, 9, 66, 35, 16, 13, 94.5, and then 200, 10, 300, 910. Okay, now that I have my matrix typed in, I'm going to quit and get out of this window. I'm going to go back into the matrix. I'm pushing second, going back into the matrix, and this time I'm going to choose the second tab where I'm going to perform the RREF. I'm going to row reduce these rows into echelon form. All right, so if you scroll down to B, okay, we're going to choose RREF. I'm going to go back into my matrix, and this time under the names tab, I'm going to just choose that first matrix where I typed in all of my numbers. Okay, and our calculator solves the system for us, telling us that the first row is 1.5, 1, and then 2. So 1.5, 1, and 2. And then now what we need to do is we need to interpret the results from the matrix and from the calculator. So what this tells us, remember this is x, y, z. Since the leading coefficient in this first row here goes with the x, this tells us that x is equal to 1.5, right? In the second row, the leading coefficient corresponds with the y, so this tells us that y is equal to 1. And then in the third row here, it's the third column that has the leading coefficient, so that tells us that z is 2. So what this tells us is that we need to give our patient 1.5 servings of chicken, okay, 1 serving of corn, oops, I misspelled that, corn, and 2 servings of milk. So if we do this, our patient will get the correct number or correct amount of protein, carbs, and calcium. So that's really beautiful, and it was really nice that we were able to use technology to solve this problem. But remember, in order for us to use technology, the most important part was to get the equations for the system. So we had to make sure we got that right before we can actually start using the technology to solve this problem.